Good morning. It's a pleasure to be here. A little bit daunting as well. I guess the first thing is I need to designate one of you to be the one that catches me when I roll off the stage. So I'm going to talk to you a little bit about why you should think about people with disabilities in your education programs and employment. And first want to ask you as a question is, do you recognize any of the people in those pictures? So probably not. I didn't expect you would, but you should. You really should. Those are some of America's most prominent scientists and physicians. All of them have won major scientific and medicine awards, and 3 of the 5 are actually members of our national academies, and they are all people with disabilities. So it's Lisa Iazzoni and Hugh Hare and Margaret Steinman and Pat Craig, who is actually from Squirrel Hill in Pittsburgh, and my good friend David Gray. And so, that's part of our problem, is that we don't know about people with disabilities that have done great things. If we don't convey that to students with disabilities, they don't know that they can go on to do great things. And this is a worldwide problem. There are 80 million people in the world today who need wheelchairs and don't have access to them. There's only 20 million people in the world that even have access to a wheelchair of those 80 million, and there's only 6 million wheelchairs produced each year, and of those 6 million, 3 million of them are used by the United States and Europe. So it's a huge problem. And also, you probably don't realize you have people with disabilities in your workplace and in your schools today. A lot of them are not obvious, like my friends on the slide or myself, but they are there. And they're a part of our families, and they're part of the fabric of American culture and of our world culture, and we need to work harder to get them included. And as we go on in STEM careers or in advanced sciences, it's PhDs, they become less and less represented. So there's even fewer of them in academia, fewer of them in industry, and fewer of them leaders. And we need to change that. And it's a tremendous loss in resource. What are some of the barriers that we have? And one of them is how we teach science, which is great because I heard that in some of the previous speakers too, that if you don't catch people's attention and you don't engage them, and we don't teach people in a way that they want to be pursuing those areas, you're not going to get them to follow that pathway. And that's part of we have with people with disabilities. And believe it or not, many people with disabilities are already experts in many areas of technology and science. They use a wheelchair, they use an augmentative communication device, they use computer access technology, they're using smartphones. If you can engage people in saying, let's see how the technology that you're using is developed, how that is part of science. Engage other students with and without disabilities, because that's the community we live in, right? People with disabilities, people without disabilities, all kinds of diversity living together. If we're not included, then our perspective is not, society is not benefiting from our perspective. Now, part of that is accessibility of the equipment and facilities, which is somewhat ironic because if you go backstage, you will see all the complicated processes that went through to actually allow me to sit on this spot and speak to you today. And if we think about that in design, we make it an engineering problem. To give you a little bit of an example, when I first got injured while serving in the Army, I came back and I enrolled in college, and I went in, and I'm an engineer, and so I was coming to the engineering school, and the faculty said, "Oh my God, a person in a wheelchair. Let's see, we'll drop this lab, maybe we'll insert this other course instead." And we had this discussion, and I don't know, I was a young man, and maybe because I was a sergeant in the Army, I said, that just really doesn't sound like it's going to work. What it sounds like is that I'll get a degree, but I won't be trained like the other students. And if I don't get trained like the other students, I won't get a job. And and the faculty actually said, you're right. We're engineers. This should be an engineering challenge. And we worked over my entire 4 years to make the curriculum accessible. So How can we get you to the labs? How can we lower equipment, put it on different benches? And I think using that creativity, we can make science more inclusive so that people with disabilities are not observers and note takers, but full participants. And we have a lot of opportunities now because we use computer simulations, computer-aided design, computer-aided manufacturing, computer-aided engineering, robotics technologies. In our labs at the University of Pittsburgh, we're actually now using robotics so that students with very high disabilities, as you can see in some of the pictures there, can use robots to actually do laboratory experiments and help conduct those experiments that they can't do. We're using voice control for complicated machines so that they can, if you don't have the ability to use your arms, you can use those. And cognitive aids are looking at how we restructure our curriculum, how we teach things so that students can participate. Then we also have to advise students. They have to know that they can do this. You have to tell them that you don't have to study social sciences or political science or law, which are perfectly good pathways to follow, not exactly along my passions, but that you can open up other fields as well, biology, chemistry, physics, and heaven forbid, engineering. And then guide them through those pathways. What's the right way? You need to work on your math skills. You need to take these physics classes. You need to take these chemistry classes and work with teams. I also think everyone benefits because you get students without disabilities and students with disabilities working together, and they learn from each other. And we do this actually with some actually very simple technologies. The Lego Mindstorm kits are kind of a great tool for teaching science to kids in middle school with and without disabilities, because you've got some programming, you've got easy assembly, and you can extend upon that by the way, very simply nowadays using 3D printing technology, where you can actually have the students do some CAD work, and from that CAD work they can design parts and print them in 3D and add them to the Lego Mindstorm kit so they can customize them. And you get a little bit of more creativity beyond just a little simple programming and assembly. So some of the other facilitators is we have to attract people with disabilities here. We have to hold them into it, and we have to engage them in STEM. One of the things that we have found that's very successful is using technology for people with disabilities and for older adults. So just use my wheelchair as an example of technology. So you can see I have a carbon fiber backrest. You could talk about composites this way. You can actually have a carbon fiber side guards and I have carbon fiber back underneath. It's a titanium frame. The spokes are Kevlar. So the carbon fiber is lightweight. The titanium is very durable. It's abrasion resistant. Actually, if you look closely, you can see the scratches from taxi cab drivers and airline transportation. And then and the spokes are kind of interesting because if you were to take the spoke off, it'd be like a noodle. And so instead of a rigid spoke, it's a Kevlar spoke. And then it's got a little plastic cover so that the Kevlar stays protected. And then we can talk about the machining processes. And that engages everybody in this process as well. And then, of course, other things like some people with disabilities, they have their phone, and we call them add cognitive aids. Sometimes they're just as simple as apps. And now, of course, we can see things about using wearable computing or these smart devices that we carry around with us to monitor our own behavior and hopefully move us towards more positive behavior rather than sitting on Facebook for 3 hours a day. So I'd like to give you some examples of actual students that work with me and have gone on to be successful innovators or will go on to be successful innovators and entrepreneurs. And in the upper left, that's Joe Olson. Joe is a mechanical engineer. He has a small company that uses computer-aided design and 3D printing to make custom devices to customize power wheelchairs. So that little red, funny-looking thing with a bunch of holes in it is actually the handle that Joe developed while he was a student at the University of Pittsburgh for his joystick. Because just a little small ball he had a hard time when he was driving over the wonderful sidewalks that we have and how smooth and flat Pittsburgh is, and keeping his hand on the joystick. And so he had this ergonomic shape that fit his hand. And he has learned, actually, using some freeware developed by our close friends and colleagues at Carnegie Mellon, where you could take some photographs of your hand. He could convert those photographs into shells or 3D images, put that into a CAD program, and then he makes a custom handle. You set your hand on it, it sits sort of comfortably in its own saddle. And he made a little business out of that. And he doesn't actually even own a 3D printer. He does the CAD work and then basically farms it out to companies that will do the turnaround. And he's got his process down well enough now that he can have it sent directly to your home. Now, Joe his business hasn't got to the point where he can live off of that. Although he's gotten some small grants, small business innovative research grants, and some other things to get him started. What he does as his day job is actually monitor all of our communications for the NSA. So, but he is working on on doing something that may be a little more productive, maybe. Next to Joe on the upper right, that's Ian Rice. Ian was a gymnast in high school and had an accident in a competition and wound up with a high cervical spinal cord injury. And so Ian is now a professor at the University of Loyola Urbana-Champaign. He's also an occupational therapist. He studied with us at the University of Pittsburgh. And like myself, you can see in the picture he's actually participating in an experiment to look at transfers. How do you take your wheelchair on and off the toilet and also into wheelchair propulsion to preserve your upper extremity strength? And so he worked on the smart wheel, and Ian and I worked, and that's that picture up there. And then what the smart wheel does is when you push your wheelchair, it measures how hard you push and what direction you push in order to make your wheelchair propulsion more efficiently. And now he's doing that for wheelchair racing to hopefully help the United States win more medals in 2016 in the Olympics. Since in the last several years we've gotten beat up rather handily by the British, the Germans, and the Chinese. So we'd like to regain a little bit of our pride. In the lower left, that's Elaine Houston. Elaine was born with several disabilities. Primarily, probably most severe among them is her hands didn't form. So Elaine has been working with me on a project called PERMA, Personal Mobility and Manipulation Appliance. She came to me actually as a research experience for undergraduate student, and she said, I really like that wheelchair you're building with the dual robotic arms. And she said, I'd like to get one of those. And I said, you can have one. You just have to come to graduate school at the University of Pittsburgh, and you can work on that project. And so Elaine wants to do robotics, and she's actually a Carnegie Science Center award winner. And then the last person is Rachel Cowan. And Rachel Cowan is at the Miami project. She has a spinal cord injury that she received from an accident while in high school. And Rachel is working on curing spinal cord injury. And so what she is doing is she's also an engineer, so she's not looking at the molecular and biological side, but she's looking at how do you preserve function as people work on the molecular and biological side, and what type of functional activities do you have to do to promote recovery when things like stem cells or other types of interventions are successful. Fun thing about Rachel, well, actually, when Joe came to Pittsburgh, his mother came for the first 6 months and lived with him. And so we can teach Joe to be independent. And Rachel, actually, the same thing happened with her. Now Joe lives on his own. His parents are up in Michigan. He's out in Maryland. Rachel's parents are in Kentucky, and she's down in Florida. So there's not only have they become great scientists, role models, but they live independently as well. So thank you very much.